Math 2, finding key features algebraically from standard form. Standard form is f of x equals ax squared plus bx plus c. So we're going to step through how to find all of the key features algebraically from that form. Let's start off by identifying the a, b, and c values from this example that we're going to work with the whole time. A is the number in front of the x squared term, so a is 2. B is the number in front of the x term, so b is negative 4. C is the constant in the back, so c is negative 6. We're going to use those values throughout this lesson. In order to find the axis of symmetry, you have to memorize this equation. You're going to use x equals negative b over 2a. So you just plug all the numbers in and simplify. So x equals the opposite of b. Our b value is negative 4, and then over 2 times a. So you just simplify. Up top, the double negative turns into a positive. In the bottom, 2 times 2 is 4, and then 4 divided by 4 is 1. Since this is an axis of symmetry, you do need the x equals in front of the 1 to get full credit, because this is that vertical line that cuts through the vertex, and it just cuts your parabola in half. For x-intercepts, you're going to let y equal 0 and solve for x. Cool thing about x-intercepts is you would use that same method for any function, because if you just visualize it and think about it, here's a little graph here to visualize it. If I'm on the x-axis, so right here in green, if I'm on the x-axis, I haven't gone up, I haven't gone down, so y has to be 0. So that's why we let y equal 0, and then we just solve for x. Let me get rid of all this stuff for later. All right, so back on our problem, we're going to let y equal 0. In this case, f of x is going to be 0, because remember, f of x and y are basically the same thing, just different notations. So here's our equation, set equal to 0. And then we're going to factor, set each factor equal to 0, and solve for x. So basically just that solve by factoring lesson from a couple days ago. So whenever I'm trying to factor, I always want to divide out a greatest common factor first if one exists. So on this problem, all of those terms are divisible by 2. So I'm going to divide everything by 2. Then, looking at my leftovers in the parentheses, I see a basic trinomial. So I want to find two numbers that multiply to negative 3, and those same two numbers are going to add to negative 2. So we have negative 3 times 1 is negative 3, and then negative 3 plus 1 is negative 2. So I'm going to do x minus 3 and x plus 1. From here, we want to set each factor equal to 0 and solve for x. Two ways we could deal with this 2 in the front right there. We could just divide both sides of the equation by 2 to get rid of the 2. Or the other way to think about it, you could just count 2 as a factor and set it equal to 0 like this. So I'm taking all my factors and setting them equal to 0. And then when I go back to that first one, 2 equals 0, 2 does not equal 0. That doesn't make any sense. So you just cross that out. It doesn't make any sense. You just ignore it. And then as far as the other equations, just solve for x. So x equals 3 and x equals negative 1. Now, since we're finding x-intercepts, let's go ahead and write our final answers as ordered pairs. So 3, 0 and negative 1, 0. Let's plot those on our graph up here. So 3 and negative 1. So negative 1, 0 and 3, 0. And while we're at it, let's put in our axis of symmetry. That was at x equals 1. And sure enough, visually, you can see that that axis of symmetry is right smack dab in the middle between the x-intercepts. Because remember, x-intercepts have to be the same distance away because parabolas are symmetric with respect to that axis of symmetry in the middle. All right, concavity, our favorite. We love concavity. It's so easy. You just look at your a value in the front. If a is positive or greater than 0, you're concave up. If a is negative or less than 0, you're concave down. Remember, concave up looks like this, concave down looks like this. So on our problem, a equals 2, which is a positive number, so we are going to be concave up. Moving right along, the vertex. If we want to find the vertex from standard form, we want to find the x-coordinate of the vertex, which, convenient for us, the x-coordinate of the vertex is the same as the number from the axis of symmetry. So we already did that. We already got that. It's 1. So now that we know the x-coordinate of the vertex is 1, we just need to figure out the y-coordinate of the vertex. So we're going to take 1 and plug it in for x in the original function. So I'm taking the x-coordinate of the vertex, I'm plugging it in for x in parentheses in the function. And then I'm just going to simplify, following order of operations. So in that first spot, I do not do 2 times 1 and then square it. Order of operations says I have to do exponents first. So 1 squared is 1. So that's 2 times 1. And then negative 4 times 1 is negative 4. Back up in the front, 2 times 1 is 2. And then 2 minus 4 is negative 2. And then negative 2 minus 6 is negative 8. And then at the end, make sure you write your vertex as an ordered pair x comma y. So the 1 was coming from the negative b over 2a, and then the negative 8 is what we just found. So let's go plot that. 1, negative 8. 1, negative 8. So here's our vertex down here. And then last thing, y-intercept. Let x equal 0 and solve for y. Or, since we're in standard form, it's always 0, comma, whatever the c value is. And you'll see why in just a moment. So I'm letting x equal 0. And then I'm plugging in 0 wherever I see x in the original function. So here's why we've got this nice little shortcut that it's just 0, comma c. Here's why. When I plug 0 in, 0 squared is 0. Negative 4 times 0 is 0. Back up in the front, 2 times 0 is 0. So everything cancels out except for the c value in the back. And then make sure we're writing our y-intercept as an ordered pair x comma y. So if you want to just use the shortcut and know that it's always the c value when you're in standard form, you can do that. And remember, this right here, let x equal 0 and solve for y, that would work for any function if you want a y-intercept. Because if we look at our graph here, if you're on the y-axis, you haven't gone left, you haven't gone right, so x has to be equal to 0. So that works for any type of function, not just quadratics. All right, so what do we get? We got negative 6, 0, negative 6. So let's take our pen and put a y-intercept at 0, negative 6. And then as far as actually drawing in this parabola, I have 4 points on my parabola. Let's go ahead and take this y-intercept and just flip it over on the other side of the axis of symmetry. Because it was 1 unit away, so I went 1 unit away on the other side of the axis of symmetry. And I'm just going to do the best I can to connect these dots, and there's my parabola going concave up. At this point, why don't you pause the video and try the practice problem on the second page, and then when you're done trying it out, you can see if you did it correctly. So for your vertex, you want to do the x-coordinate first, which is the same as the axis of symmetry. So that's x equals negative b over 2a. You want to have that memorized. We're not going to give that to you on a formula sheet or anything. You have to know that off the top of your head. Let me backtrack a second and jot down the a, b, and c values. So a is the number in front of the x squared. So since there's nothing there, it's an invisible 1. B is the number in front of the x. C is the constant in the back. All right, so negative 8 over 2 times a is going to simplify down to 4. So that's my x-coordinate of my vertex. And then now I take the 4 and I plug it in for x in the original equation, and then just simplify following order of operations. So 4 squared is 16. Negative 8 times 4 is negative 32 plus 15. 16 minus 32 is negative 16. And then plus 1, or plus 15 is negative 1. And then make sure we write our answer as an ordered pair. And let's go ahead and plot that right away. So 4 over, 1 down. There's my vertex at 4, negative 1. Y-intercept, I'm going to use the shortcut. It's just the C value. So 0, comma, 15. That's one of those times where you can get away with not showing your work. So 0, comma, 15. For x-intercepts, we want to let f of x, or let y, equal 0. And then we're going to solve for x. So we have x squared plus, not plus, minus 8x plus 15. So I'm going to try to factor that. I need two numbers that multiply to 15 and add to negative 8. So let's try negative 5 and negative 3. And then set each factor equal to 0 and solve for x. So we're getting x equals 5 and x equals 3. And we do want to write our answers as ordered pairs. So 5, comma 0 and 3, comma 0. And then let's plot those on our graph. So 5, 0 and 3, 0. Moving right along, axis of symmetry. Love it because we already did it. It was negative b over 2a, which we did back over at the vertex. So x equals 4. Axis of symmetry is always x equals whatever the x corner of the vertex is. Concavity, again, we love it. Just look at your a value. A is 1. That's positive. So we're going to be concave up. Uh-oh. I'm frozen. Hold on. Let me exit out of this and see if I can get unfrozen here. I'm still frozen. Hold on. Hopefully this will work. I don't want to be frozen. There we go. Okay. So we said we were concave up and domain. Okay, so let's do, I don't think we put our y-intercept on our graph. Let's get our y-intercept on our graph and draw our graph in. So I'm going to go up to 0, 15. And then I'm also going to put in my axis of symmetry through my vertex. So there's my axis of symmetry going through my vertex. My y-intercept is 1, 2, 3, 4 units away. So let me go 4 units on the other side. 1, 2, 3, 4. Just to get a little bit more of an accurate sketch of my parabola. So there's my parabola. And then now that we can visualize this a little better, I'm going to do my negative infinity on the left, positive infinity on the right, negative infinity on the bottom, positive infinity on the top. And then I'm going to put in my, let me slide this down a little here. Put it by the x-axis. There we go. And then our axis of symmetry, our vertex, is at 4. I drew all that stuff in because it usually helps us with the intervals of increasing and decreasing, and then it also helps a little bit with domain and range. Speaking of domain, domain is all of your x values going from little to big or left to right. So this parabola just keeps going forever and ever in both directions. So our domain is simply negative infinity to infinity. Range is all your y values, little to big or bottom to top. So if I'm, down here, there's nothing. Down here at the bottom, nothing, nothing, nothing. My first y value that I get to is right here. This is a y value of negative 1. So from negative 1, I just keep going. Up and up and up forever and ever and ever. So my range is going to be square bracket, because I want to include the negative 1 in my answer, negative 1, comma, infinity. So that means my lowest y value is negative 1, and then I go up forever. For interval of increase and decrease, look at your parabola from left to right. So I'm going down, I'm decreasing on the left. So from negative infinity to 4, right, the x coordinate of the vertex. So from negative infinity to 4, I'm decreasing. So negative infinity, comma 4, I'm decreasing. Then, other half of the graph, from 4 to infinity, right? I'm talking x values, From when x is 4 to when x is infinity, this parabola is increasing. It's going up forever and ever and ever. So from 4 to infinity, we're increasing. And then that should be everything.